Differential equation. Before going to the definition of differential equation, let us consider one example of differential equation. Consider one equation like this: d square y by dx square minus y dy by dx plus x equal to 0. This is one example of differential equation. Now, here two variables are there, that is one is y, another one is x. Now here we know that y equal to fx be a function where x is the independent variable and y is the dependent variable. So two variables are there, one is independent variable x and the variable y which is dependent variable. And dy by dx is the derivative of y with respect to x. Similarly, d2y by dx square is the derivative of second order. So, since this is a differential equation which contains dependent variable y, independent variable x, and its derivative like dy by dx or d2y by dx square. So, from this equation, we can say the definition for differential equation: an equation which contains dependent variable, independent variable, and its derivatives is called a differential equation. Now, generally we have two types of differential equation. One is ordinary differential equation, another one is partial differential equation. In case of ordinary differential equation, it contains only one independent variable and one dependent variable. For example, we consider dy by dx plus y equal to x. This is the example of ordinary differential equation where y is the dependent variable and x is the independent variable. Only one dependent and one independent variable is present in this differential equation, and this derivative is ordinary derivative. So that's why this differential equation is called ordinary differential equation. Now go to the partial differential equation. In case of partial differential equation, it involves one dependent variable but more than one independent variable. That's why this differential equation contains partial derivatives. So this differential equation is called partial differential equation. For example, we can write if z be the dependent variable and which is a function of x and y, then we can write the partial differential equation del z by del x plus y into del z by del y equal to 0. This is an example of a partial differential equation of first order. Similarly, we can write del 2z by del x square plus del 2z by del y square equal to 0. These are the example of partial differential equation. In case of partial differential equation, it contains partial derivatives. That's why this is called partial differential equation. Now, order and degree of a differential equation. The order of a differential equation is the highest order derivative or differential coefficient that present in the differential equation is called order of the differential equation. The degree of the differential equation. Now the degree of a differential equation is the exponent of highest power of the highest order derivative, that is called the degree of the differential equation. Now go to the example. Consider the first example, d2y by dx square plus x into dy by dx. Here, the highest order derivative is d2y by dx square. That is, the order of the differential equation is 2, and the degree of the differential equation is 1, since the highest order derivative whose degree or exponent is 1, that's why this degree is 1. Now go to the second example. If you consider the second example, d2y by dx square star whole square plus x into dy by dx whole cube plus y square equal to 0. Now in this differential equation, the highest order derivative is d2y by dx square. So the order of the differential equation is 2 and its exponent is 2. Exponent is 2. So degree of the differential equation is 2 also. Next, we go to third example, that is d2y by dx square equal to y square plus dy by dx whole to the power 3 by 2. Now, if you see this problem, so first of all, we have to rationalize this differential equation. So if we rationalize this differential equation, we can write the differential equation as d2y by dx square whole cube equal to y square plus dy by dx whole square. Now, the highest order derivative is d2y by dx square, so order of this differential equation is 2 and its power is 3, so that's why the degree of the differential equation is 3. Now we go to the last example, that is the fourth example, that is d2y by dx square plus sine of dy by dx equal to 0. Now in this differential equation, the highest order derivative is d2y by dx square and its degree is 1, but since dy by dx is contained in x, means within sine, so that's why the order of the differential equation is 2, but the degree of this differential equation is not defined. Similarly, if log x within log x dy by dx within exponential function dy by dx or d2y by dx square, if any derivatives is there, then that differential equation has a order, but that differential equation has no degree.